Hey everyone, in this video we'll go over some different types of descriptive statistics and how to calculate them. So descriptive statistics are a set of techniques for summarizing and displaying data. Most of the time your research project will want to test something specific about a relationship between two variables or the effect of X on Y, but it's still important to describe and visualize your data, and every research paper lists out descriptive stats. But before we get started, I want you all to pause the video and go download JASP. JASP stands for Jeffrey's Amazing Statistical Program. The Jeffrey's part refers to a Bayesian statistician, but that's not totally relevant here. Anyway, go to this link and you're going to want to click the download button near the top of the screen. You can download this no matter if you have a Windows or a Mac or Linux computer, so it should work for everyone. You should download the newest version, but make sure you're installing version 0.10.1.0. It should take around 10 to 15 minutes to download and install, and make sure you install it in a place where you can find it on your computer. So why am I making you download JASP? This is because I'm not going to make you calculate any statistics by hand, so we'll use statistical software to do all of this for us. When you take Research Methods 3020 or Part 2 of Research Methods, it will be pretty much all statistics. And you'll more than likely use a program called SPSS for that class. And depending on your instructor, you might use something else, but mostly undergrads use SPSS. I personally don't like SPSS for a few reasons. First one, it's slow and clunky. Another reason is that I find some of the tests to be a little confusing on there. JASP, on the other hand, is a lot faster to run, and I find the user interface to be a little more intuitive. The main reason, though, I would say that I don't like SPSS is because it's not free. It costs the university money each year to get a license to use it. That means that you can't have SPSS on your own computers. You either have to use a university computer or the university's virtual network, software anywhere, which is also kind of slow and clunky. JASP, on the other hand, it has all the functionality of SPSS, and importantly, it's completely free, so you can always keep the program on your computer. You can use it anytime, anywhere. So that's why I'll be showing you how to do some things in JASP. So if you, for some reason, are having trouble downloading or installing JASP on your computer, just shoot me an email and we can figure it out. Okay, so the first thing to talk about is the distribution of a variable. This is the way scores are distributed across the levels of that particular variable. So it shows you where all the responses are. You can display the distribution of a variable in a couple of ways. The first is through a frequency table, which is a table with all possible levels or values of a variable, and then the frequency, or how many times they occur at each level. So if we had a variable measuring self-esteem levels in people, we have our frequency table on the top right. The left column shows all of the values that were reported by people in our sample, and the right column shows how many responses there were at that particular value. So 3 people had self-esteem values of 24, 5 had values of 23, 10 people had values of 22, and so on. The next way you can display a distribution would be to plot a histogram. This is a graphical way to display the distribution. It's showing the same values that the frequency table shows, but in picture format. So on the x-axis, we have the different levels or values of self-esteem, and on the y-axis, it shows the frequency, or how many at each value. Histograms are a little easier on the eyes, and I think it's an easier way to show the distribution of a certain variable. Okay, so now we'll get our first introduction into how to use JASP, and we'll learn how to do a frequency table and histogram. So go ahead and download the booksales.csv from the week 8 module. And we'll go and open this up now. So when you open up JASP, this is what it looks like. And the first thing you want to do is import your data. So you want to import that booksales CSV. And to do that, you're going to go up to these 3 little lines up here. And you're going to go to Open, Computer, and just go ahead and browse your folders. And just wherever you stored that CSV or Excel sheet on your computer, mine's in a data folder, and book sales. So I'll go and highlight that and hit Open. and it loaded the data set in there for me. So the first thing you'll note is that it kind of shows you what the data looks like. And this is what it's going to look like if you actually opened up the CSV. So up here we have our columns. These are our different variables. So we have, in this case, month, days, sales, and stock levels. And then we have rows 1 through 12. You can think of rows as individual data points or people. So in an experiment, you would have like person 1, and they have all these measurements, person 2 with measurements, person 3, and so on. So to calculate a frequency table and a histogram, it's going to be under this Descriptive Statistics box here. So if we click that, there's two options. We want to click Descriptive Statistics, and it kind of changes view. To get back to the data view on the left side here, you can hit this arrow, and it'll kind of minimize it and show you the data. And to go back, it moves to the right side. And click that again, and it'll get back to the stats page. All right, so what do we want to look at here? Let's look at days. So we can find days on here. We can highlight it, and then we're going to move that over to variables by just clicking this little arrow, and it moves days over there. All right, so we want a frequency table, and conveniently, it's listed right here as frequency table. So if we just click that, it'll just automatically kind of populate that and calculate it and show you the results here on the right side. So here we have our frequency table. We have the days, so 28, 30, and 31. Those are all the reported values, and frequency. So there was 1 occurrence of 28, 4 occurrences of 30, 7 occurrences of 31. So there is our frequency table. And the next thing we want to do is to create a histogram. So that will be under this plots section. So if we click plots, it'll kind of show us the options of what we can do. And for here, the distribution plots will be the same thing as a histogram. So if we check distribution plots, and if we scroll down, it kind of just tacks on the results as you add more things. So here we have our distribution plot, or it's the same thing as a histogram. So it looks a lot different than kind of what we show and read in the books, in the textbooks, but that's just because this data set isn't very big. If it were a lot bigger and had days ranging from 14 days to 31 days and had hundreds and hundreds of people, you would see a more characteristic kind of peak in the middle. But anyway, here's our histogram that shows pretty much the same thing as the frequency table. And there you go. So that's how to calculate or show your histogram. And also, if you ever want to copy these results into like a Word document for like a homework assignment, we'll have to do that a little bit for this class. Each section, a down arrow kind of appears, and so you can hit that, and all you do is hit this copy button, and that'll copy it, and it copies to your clipboard, and you go into Microsoft Word and you just paste it, Control V, and it'll paste this whole table into Microsoft Word for you. And you can do the same thing for your histogram. You hit the down arrow, you copy it, and then you go and paste it into Microsoft Word. All right, so that's how you calculate frequency tables and distribution plots. Next, we can talk about distributional shapes. When we plot up a histogram, it has a shape. All histograms have shapes. A typical histogram will have a peak in the middle of it, and it will have tails off to each side. This is also referred to as a unimodal distribution, which means uni, there's one peak. There can also be bimodal, so bi for 2 peaks distributions. This is less common in research, but you do see them sometimes. So on the bottom graph, you would see 2 peaks on the left and the right. For unimodal distributions, you can also assess the symmetry of it. If the peak appears to be in the middle, like the middle picture here, that would be a symmetrical shape. If most of the responses bunched up towards the right side of the graph, like in the green picture, we would call this distribution negatively skewed. And in the orange picture, if all of the responses bunched up towards the left side of the graph, this would be called positive skew. It's always confusing to me to keep track of which is positive and negative skew, but it's just something to remember that if it's bunched up on the right, it's negative skew, and if it's bunched up on the left, it's positive skew. Moving on, in descriptive stats, we always report a measure of central tendency. Central tendency describes the middle part of a variable's distribution. And there are three ways we can report central tendencies. You're probably already familiar with these, but the first is the mean, which is the sum of the scores divided by the number of scores. The second is the median, which is the middle number. So if you organize the scores from low to high, you would find the middle number, and that's your median. And then the mode is just the most frequent score in a distribution. So you look for the value with the highest frequency, and that's your mode. Okay, so now I'll show you how to calculate the mean, median, and mode in JASP. So we'll still use the book sale CSV file, and we'll head over to JASP, and I'll just go ahead and import this data set again real quick. Okay, book sales. And here we go. So we'll go back under Descriptive Statistics here. Loads it up for us. And we'll still look at days. So we'll highlight days, plug it over to variables. And you might have noticed this before when we were doing our frequency tables and histograms, is that it kind of, as a default, shows you some of these descriptive statistics. So here we have a table. There's 12 valid rows, no missing data. So we have our mean here, 30.417. It also gives you standard deviation. We'll talk about that in just a second. But we also need to calculate the median and the mode, so the other two central tendency measures. So to moderate this or to change the options, it will be down in this little statistics section. So we can uncheck that. And kind of on the right side, central tendency, we have these two options. So let's just check median and mode. And then it automatically updates this table for us. So now we have mean 30.417. We have our median, which is 31, and our mode, which is also 31. So that's how you calculate mean, median, mode in JASP. And again, you can hit the arrow and copy this whole table and paste that into Word if you're doing a homework assignment. Okay, so other than central tendency measures, we also want to describe the variability. And this is the extent to which the scores vary around their central tendency. So how much do they bounce around? These two figures here have the same measures of central tendency, so they both have the same mean, the same median, and the same mode. But we can tell just by looking at them that they are not the same. The top graph hugs tightly around the middle with small tails. The bottom graph is a lot more spread out with the tails of the distribution going out farther than the top graph. So this is why it's important to also describe the variability of a measure. We'll talk about three ways we can describe the variability. The first is the range, and this is just the difference between the highest and lowest scores. So you take the highest score minus the lowest score, and that's your range. We also have the standard deviation, and this is the average distance between the scores and their mean. So how much does each score deviate or differ from what the grand mean is? And then there's the variance, which is similar to the standard deviation, which is the mean of the squared differences. Okay, so now I'll show you how to do range, standard deviation, and variance in JASP. We're still using the book sales data, and I already have that loaded up. So we'll go ahead and go back to descriptive stats. And we want days still. Okay, so we can see likewise, like before, it already has the standard deviation 0.9. So we also want to add the range and the variance onto that. So we can go back down to statistics down here. And dispersion, that's kind of our variability section. So we have standard deviation checked. So we can also check the range and the variance. You can make this kind of a good habit is to, whenever you load up a data set and you want to do descriptive stats, just go down to the stats section and just go ahead and check a bunch of stuff, even if you may not need it. So do all the central tendency measures, do all the dispersion or variability measures, and then you have your nice neat table of descriptive stats. So standard deviation 0.9, we have our variance is 0.81, and our range is 3. And we can also do this with other variables. So if you ever wanted to get rid of this days, you can just highlight it and this arrow flips and you can just send it back to the left. And we can do or check out sales. So now we have our sales measure and it just kind of auto updates and repopulates these values. We already have these checked, mean, median, mode, standard deviation, variance, range. And now our mean for sales is 29.167. Median is 0, mode is 0, and we have our measures of variability too. So that's how you kind of package this up, including central measures of tendency and variability in JASP. Some other things you should know is percentile rank and z-scores. Percentile rank is the percentage of scores in a distribution that are lower than that score. And you're probably already familiar with this when you think of ACT scores from high school. You would get your score, and by that it would say you scored in the 70th percentile or whatever. So that would indicate that 70% of people who took the same test scored lower than you. And we also have a z-score, which is the difference between an individual's score and the mean of the distribution divided by the standard deviation of the distribution. I know that's a mouthful, but I'll show you how to do it in just a second. But z-scoring is important because it puts everything on the same scale. So say you wanted to compare and see if one person did better on their biology test than another person did on their chemistry test. Well, those would be hard to compare because they are two different tests with different questions and different answers. But if we z-score everyone's test performances, we're essentially forcing them to be on the same scale, which enables us to compare across tests. So in essence, it allows us to compare apples to oranges. So now we'll do the percentile rank and z-scores in JASP. We'll still use the book sales data. For z-scores, things will be not as easy as before, but we can ask like a question like, where does 31 fall? For that, we need the following info. We need the mean and the standard deviation of it. So if we're using the days variable, we'll have to take that 31 minus the mean, which is 30.417, and divide that by 0.9, and we get the z-score for 31 is 0.648. So we would interpret that as 31 is 0.648 standard deviations above the mean. And we'll need just a tiny bit of code to put into JASP, but I have the code here, so you can just copy and paste it right into JASP. So we'll go ahead and do those things first. All right, looks like I don't have the data loaded, so I'll go and reload that. Book sales. Okay. So let's do percentile rank first. So we'll go to descriptive stats and we'll choose our days variable and move it over to variables. And under statistics, it's pretty much the first thing you see. So it's percentile values, and we will choose this percentiles and we'll put in a percentile here. So say we want to know what the 20th percentile of days is. So we'll hit 20 and hit enter, and you can see it auto populates over here on the right side. 20th percentile is 30. And we would just kind of manipulate these values for whatever we need. So if we wanted to know the 50th percentile, we would type in 50, hit enter, And there you see it kind of updated. So the 50th percentile for days is 31. So that's how you calculate percentile ranks in JASP. And the next thing we want to do is to z-score a column. So you can do it by hand using that formula, but it's a lot easier to make computers do this kind of computation for you. So we'll go ahead and we can just minimize this whole descriptive statistics section. We can minimize it, and this is nice, this little workflow. So as we move on to do like inferential testing, we'll have our descriptive stat section, and then below it we'll have another section. You can have sections and sections, and it's nice to show kind of an organizational flow there. But we want to go back to the data view. So on the left, we'll kind of hit this arrow, and now we're back in our data view. So we want to z-score not just one of these numbers, but the entire column all at once. So we're not going to manually edit this column. What we want to do is kind of make a copy of it and change the copy of the numbers. So to do that, there's this little plus button here, and it says create a computed column. There are two options. I want you to choose the one with this R, and we can give this a name, and we'll call that days C. And so we want to choose R because we have to put that teeny little bit of code in there, and then we can go ahead and hit create column. And so it changed it up a little bit. So there's a section up here where you can put in code, but you still also have the data view down here. So we have our days, and then we have an empty column that we created called days_z for z-score. Okay, so what was that code? It was scale as numeric as character days. As dot numeric. Close. Okay, you don't really need to know what the code means, but basically we take our days column here and we make it into a character string. We force that to be a number, and then this scale function will do that z-score computation for us, and it will automatically apply it to this entire data set. So we have our code here. We just typed it out. Oops. And we can hit compute column, and there we go. So we have our z-scored 31, which is 0.647. And this pretty much matches up with our example here. If we were to do it by hand, 0.648, so that's a rounding issue on my part. But it did that for all of us. So that's how you would z-score data in JASP. We've talked throughout this course about experiments that compare the differences between groups or conditions. Well, we could do a couple of things for that. We would first calculate the means for each group and compare them, and we would also want to visualize the data by plotting the means in a graph like a bar graph. By now you should be pretty familiar with the bar graph and what its components are. Along with means and graphs, we also wanted to describe the strength of those differences. So X might be bigger than Y, but how much bigger? For this, we look at effect sizes, which does describe the strength of a statistical relationship. When we compare two groups together, we will use what's called Cohen's d, and this is the difference between the two means divided by its standard deviation. When you calculate this, you get a value out, and there are some guidelines on how to interpret it. If your Cohen's d is 0.2 or smaller, that's considered a small effect. If it's around 0.5, it's considered a medium effect. And if it's 0.8 or larger, it's considered a large-sized effect. If the value falls somewhere in between these guidelines, it would be a small to medium or a medium to large effect. So if your Cohen's d was 0.35, I would call that a small to medium effect. Or if it's 0.7, I would call that one a medium to large effect. Since Cohen's d values are standardized differences, they can exceed 1. So you will occasionally see Cohen's d-values of 1 point something or even 2 point something in an extreme case. And an important side note on this, just because an effect size indicates that the relationship is large, this does not imply a causal relationship. For that, you need inferential hypothesis testing, and we'll get into that in the next video. Okay, so now we'll go ahead and calculate means, make a bar graph or a box plot, and calculate Cohen's d effect size in JASP. So for this, we're going to download the clinical trial CSV from the week 8 module, and we will use that. So I'll go ahead and import our data, computer browse. So not book sales, we're looking for clinical trial. So clinical trial, we'll open that up. And here's the data and data view. We have ID, that's like a subject number. And again, each row is a person here. So person 1 was a placebo on the drug, they didn't get therapy, and this was how much their mood gained. So we have 2 factors here, or 2 independent variables. The first one's drug. We have 3 different kinds of drugs. We have 2 different kinds of therapy. That's our second independent variable, no therapy, and CBT, which is cognitive behavioral therapy. If you were to describe this experiment, this would be a 3, because there's 3 levels on this one, by 2, therapy or no therapy, factorial design or ANOVA. Okay, so first we can go up to descriptive stats. And we want to describe our dependent variable here, which is mood gain. So we'll click that and pop it over. And go down to statistics. And again, I'll just kind of click off the things, median, mode, range, and variance, even though we might not need it all. So we calculated our means here, but the other way or other thing we want to do is to visualize our data. I'll just minimize that. And so that will be under plots. So it will be box plots. Yes, that's it. So if we click that, we can see here is the overall mood gain. So it's about 0 point something. What was our mean? It was 0.83. So this is one way to kind of show the data. And this is similar to a bar graph that you guys are used to seeing, but instead, like a bar graph would kind of come up here, go across, and then back down. But this is referred to a box plot, and it kind of shows you a little bit more about what the distribution of the variable would look like instead of just a bar going up to the mean and stopping. They have some really cool options here in JASP. You can do this jitter element. So if you click that, it will, oh, there you go. It'll put all the individual data points on there so you can get an idea of the spread of data even more. If I uncheck box plot and hit violin, this is maybe, there we go. This is another way that you can kind of visualize your data, but I think box plots kind of do the trick. So we'll stick with box plots. But also, we don't want to just visualize overall mood gain. We want to visualize it split across our 3 groups or our 2 groups. So what you can do here is let's take drug, because there's 3 different types of drugs. And let's go ahead and add that over to this split section so we can hit that arrow. And we have drug. And so this is cool because it automatically recognizes now you want to split all of your descriptive stats up between the 3 groups or levels. And so now we have mood gain for anxiety-free, joyzepam, and placebo. Some pretty crazy names there. So now we have our means for each of the 3. And if we scroll down, we also have our box plots kind of vamped up a little bit. So now we have still mood gain on the y-axis, and we have anxiety-free, joyzepam, and placebo. Again, if you wanted to copy this over and paste it into a Word doc, you would just go up to the arrow, copy that whole thing, and then you can paste it into a Word document. And the last thing we need to do is to calculate Cohen's d effect size. So I will go ahead and minimize this descriptive statistics. To calculate Cohen's d, we need to go into another section. We need to go into this t-test section. So we'll go ahead and click Independent Samples t-test. And so I'm actually going to change this up. So give me a second. I'm going to go back to descriptive stats, and instead of drug, I'm going to do therapy, because that only has 2 levels and that'll work for our purposes. So again, it will automatically update all of this for us. So now we have therapy, no therapy, updated box plot. And now we can go back to independent samples t-test. All right, so variables, we want to put in our mood gain, that's our dependent variable. And then grouping variable, that's kind of the same thing as like split. And so we'll put in our therapy there. And you can see it tacked on the results section, this whole other independent sample t-test results. So here's our inferential statistics. We'll talk a little bit about that next video. But we want to click this effect size button. And Cohen's d comes already kind of selected for us. And we can see here in the last column of this little table, we have our Cohen's d, which is 0.618. And so from our notes, we know that 0.618 would be considered a medium to a large effect. So it's in between those two kind of guideline interpretations. So it's medium to large. And so now we have all of our means. We can visualize them, therapy, no therapy. And then we also have a measure of the effect size. Apart from the differences between two groups, we can also look at the relationship between two continuous variables. And we look at the correlation, which is a measure of the relationship between the two variables. You've also had some experience with this by now. To visualize the data, we use a scatter plot, which shows the scores and where they fall on both the x and y axis. Strong relationships will hug tightly around the diagonal line, and weak relationships will have dots scattered across and pretty much no meaningful pattern. Like with Cohen's d, we also have guidelines to interpret a correlation. A correlation of 0.1 or smaller indicates a small relationship. Correlations of 0.3 are medium, and 0.5 or larger are strong relationships. And this is just mirrored whether the correlation is positive or negative. While Cohen's d values can exceed 1, correlations are bounded values, so they will always be within -1 to 1. Likewise, if the correlation is between the two guidelines, you go in between the interpretations. So a correlation of 0.2, I would call that a small to medium correlation. If it's 0.4, I would call that a medium to large correlation, and anything above 0.5 is just large. Okay, so now we will calculate correlations and make a scatter plot in JASP. And we will use the Parenthood CSV file, so go ahead and download that Excel spreadsheet from the Week 8 module. And I'll go ahead and import the data real quick. Parenthood. Okay, here's our data. This is a lot bigger data set, so we have 100 rows here, and we have a few different columns. ID, we have the number of hours Dan sleeps, the number of hours the baby sleeps, and a grumpiness measure from Dan, and what day it is. Okay, so for a correlation, we want to be under this regression box, and it's going to be the first option, correlation matrix. And so say we want to look at the correlation between the number of hours Dan sleeps and the number of hours the baby sleeps. So we can highlight Dan.sleep, plug that over to variables, and then we'll also highlight baby.sleep and do the same thing. So plug that over. So now we have the two variables over here. And on the right side, we can see our correlation right there. So our Pearson's R between Dan sleep and baby sleep is 0.628. So this is a strong correlation. It's above 0.5. So there's a strong relationship between the number of hours Dan sleeps and the number of hours his baby sleeps. And it's also pretty easy to plot up this correlation matrix in a scatter plot. Under plots here, just click this first option, correlation matrix. And after a quick second, we can see here's our scatter plot. So it's the number of hours Dan sleeps and the number of hours the baby sleeps. So we see it hugs pretty tightly over this kind of diagonal, and this would indicate, if we were just looking at this would indicate a strong correlation, and that backs it up here. We see the correlation is 0.628. You can kind of jazz this up a little bit. You can hit this densities for the variables and also statistics. And so we'll recreate this plot for you, and it looks pretty cool when they do that. So yeah, we have still our scatter plot here, but we also have kind of the distribution or a density plot similar to a histogram for both Dan sleep and baby sleep. And then we also put our correlation here in the bottom left panel or quadrant, 0.628. And it gives a confidence interval around our correlation estimate, which is pretty nice too. So you can just go ahead and highlight that, copy it, and plug it right into Microsoft Word if you were submitting a homework assignment. So that's how you calculate correlation and a scatter plot in JASP. Last thing for this video is how to describe these descriptive stats in APA style. Mostly you will report the mean for your measure of central tendency and standard deviation for your measure of variability. You use the initials M and SD, and they're in italics. So you could say, for instance, classroom A, mean equals 5.23, SD equals 0.98, had higher test ratings than classroom B, mean equals 4.92, SD 1.17. Then you could also reference your graph you made and say something like, see figure 1 to show mean differences between groups. For correlations, you use the letter R in italics. So you could say there was a positive correlation between student test scores in classroom A and classroom B. R equals 0.63. I attached a p-value there, and that's how you would report the p-value next to that test, but we'll get into that next video on how you would interpret that. Okay, so that's it for the basics of descriptive statistics and how to use your new software JASP to calculate them. Hopefully this video was helpful and a good introduction to research methods too, and we'll see you next time to talk about inferential hypothesis testing.